15. Eric, let's read number 15, please.
How do you say that third word?
Theorem?
Third one?
Intermediate.
Use the intermediate value theorem to show that f of x equals x that cube, x cube minus 2x squared plus 3x has a 0 in the interval -2 and 1.
So has a 0 basically means, is there like f of x or f of c I'm going to use for the definition's sake, is equal to 0. So let's see if we can actually apply the theorem. The first theorem is, or the first thing that we have to mention is that it is what? Continuous. Let's write out f of x is continuous on the interval given. And I like to just copy what is given to us. If it's in, what was the word? Interval notation, leave it in that, right, Bella? If it's also in inequality form, leave it in that as well. So you're not changing anything. And then we need to figure out, plug in the endpoints. So my first endpoint is f of -2. And let's plug it into our function given. And just in case you mess up, write it exactly as it is by plugging it in with the parentheses. And I'll do a little piece at a time. That's going to give us -8. The next one is also -8 and -6. And that value gives us what number? A -22. So now we have f of 1. So we have 1 all cubed minus 2 1 all squared plus 3 times 1. And 1 minus 2 plus 3. How many is that? 2? Now, between -22 and 2, does 0 exist? Yeah. I see some of you guys not writing, and that's not cool. Right? So f of -2 is less than 0, less than f of 1. And then specifically plug in the values that we got. -22 is less than 0, less than 2. And then we're going to go ahead and use that little ... What does this mean? Therefore, by the IVT as an intermediate value theorem, and I am going to copy this piece word for word from left to right. You can write the function if you want to, but I'm going to stick with the f of x. F of x has a 0 on -2 to 1. And this phrase is already understood as the interval, so I'm not going to write the interval part. But you can if you want to. Okay, are we good with number 15? Yes, yes?
1 second.
1 second. Okay, if you're ready, let's go to number 21. It means therefore. IV is intermediate value theorem right here. IVT. All right. Everyone good? Thumbs up? Bella, you writing?
No, I was writing.
Okay. All right, 21. Okay, let's find the infinite limits. And there could be horizontal asymptotes, meaning it could level off to a specific number. The rule on this one, only if it's reaching infinity, is the following. You take the biggest value on the top and the bottom. Right, Sam? We're not on the Chromebook. And nothing else matters. Now, this one is it high over low, low over high, or the same? Is it low over high? And if y'all remember the phrase, it was what equals y? 0 equals y. That's it. When something is bottom heavy, it's going to reach 0 in the end because the ground is equivalent to 0. All right, next one, we're looking at number 24 and 26. I want to actually do 26 first. Was everyone good with this one?
Yes.
Okay. Okay, on number 26. Hudson, go ahead and read that one for me, please.
Let f of x equal 4x minus squared, x less than 1, x squared plus 3, x greater than or equal to 1.
All right, so we're looking at continuity. Let's underline that. And our continuity was the first one that we did. So let's kind of reiterate what's going to happen for the continuity. The first thing is the limit approaching from the left and the right must agree on the same y value, yes? Second condition is when I plug in that point, not the limit, but the point, that must exist. And third is that point must also exist the same number as the limit. Now, if any of them fails at any point, we just stop and say it's not continuous. So then, moving that card over, let's go ahead and write out left and right. When something is less than is left, something is greater than is right, and this one has equivalent to for the purpose of the point. So I think I'm going to write 1 as in step number 1. So let's find the limit on the left and the right, and what number are we approaching according to the question? 1. So limit as x approaches the 1 from the left side, meaning we are going to use the first equation. So I think I'm going to write out the equation first, and then I'll plug it in. So when I plug in the 1, we are going to get 4 times the 1 minus the 1. And that number is how many? 3. So our anticipation on the right side is hopefully it's 3. So let's make my dividing line. The limit as x approaches the 1 from the right side, and that one is going to be the bottom function. I think I'm going to write f of x. So you can choose to write out f of x instead of the function, or write the equation on there. Either or, you'll get full credit on the AP test. So let's plug in the 1. 1 all squared plus 3. That number is going to reach what? 4. So are they reaching the same y value at these 2 points right here? So is it continuous? So can I stop my proof right here? So therefore, and I think I'm going to phrase it exactly as this, except instead of continuous, use the word what? Discontinuous, or just add a not. So we have f of x. I have 2 students a little off task. Oh no. It's not continuous at x equals 1. So again, restating that original phrase will give you credit for it, or 1 extra point. All right. Yes, question.
How do you determine which one was left and right?
When it's less than, it's left. When it's greater than, it's to the right. And equal to is for the purpose of the point that we'll talk about on the top. All right. You ready for number 24? 24. Okay, on number 24, before I even start proving them, I want to go ahead and talk about what each of them stands for. Okay, when something is not equal to, that means there must be a what? A whole. When there's a whole, can it still approach the same number? It can. So this one is approaching. Now on this one, do you guys see it's stopping at a point? It's not saying x is less than. If it's less than, it's talking about all the numbers to the left. For that one, if that were to also be less than, it would be all the numbers to the left as well, or vice versa to the right. So I want you to write out something. This one is a point. The point exists at 0, 3. The third one is also a point, and that exists at where? 1, 2. This one has a hole. But even if there is a hole, and I'm going to give you an example with the picture, can the limit still approach that number? So this one has to do with the limit. So with that said, hopefully you have your card, and I did already show you guys once, so I'm not going to anymore. We are proving continuity at x equals 1. So let's go from the left and the right. Now in this case, do I have 2 different equations here? No. So if I don't have one with the inequality left or the right, just go ahead and look at the first equation. That's going to give you the limit. So let's write out limit as x approaches the 1. And I'm not putting positive or negative in the exponent because I don't have 2 different locations. It's only 1. So let's go ahead and plug this in. If I plug in, I should write this out first. So when I plug in the numbers, the 1, it's basically 1 minus 1 over 1 minus 1. What does that give me? 0 over 0. And what was a phrase that I told you guys to remember? Do more. And typically, do more means to factor, or a clever form of 1. But in this case, I think we can factor. So let's write out limit as x approaches the 1. The first one, I can take out an x. Is everyone good with that? The second one, we can also take out an x. So far, so good? All right. Are you guys okay if I go ahead and eliminate the reduced form while I'm at it? All right. So I'm going to write out the limit as x approaches the 1. And I'm writing the limit until I cannot factor anymore, and I need to plug in the number. Do I see difference of 2 squared on my numerator? Yes, I do. On the bottom, can I go any further? Nope. And I can now do what on the top and the bottom? Cross it out. And then once I have everything crossed out, what am I allowed to do? Plug in the 1 into that x. And when I do, I get 1 plus the 1, that's equal to 2. So that one is existing a limit. So our second one says, does the point exist? So let's write out f of 1. Didn't we have f of 1 right here? Where is f of 1 going to? 2? So are we agreeing with the limit and the point? So now I'm going to write out the following, and I'm going to circle the piece that we need. I think I'm going to do this one with f of x and that guy right here. So the limit, these two are going to summarize my third one. As x approaches the 1 of the function, and yes, you can write out the function, I don't want to, is equal to f of 1. So therefore, we know we can write this whole piece down without modifying. F of x is continuous or not continuous? Continuous at what point? X equals 1.